my fourth go-around as Chief Data Officer. Second time with IBM. I was with IBM from 1990 to 97 as part of their Watson Research Lab. And in 2006, I created the role of Chief Data Officer in healthcare. I did 3 stints in 3 healthcare companies before coming back to IBM to lead this effort. And in this talk, I'm really going to be talking about the cognitive enterprise. So I will share our journey at IBM with regard to creating a cognitive enterprise within IBM. So I will be telling you about what that means, in terms of, leave you some understanding with regard to what a cognitive business will look like. How is it going to be different from how things are done today versus how things are going to be done in a cognitive business. And obviously, from IBM's standpoint, our customers are enterprises, are often enterprises that look like IBM. So in that sense, what we do within IBM will also translate to our customer set as well. So there's tremendous value for us to be able to do this. We're also sharing this journey as we go. I've been at the job maybe 9 months. I joined them in December. And I've already done several talks, talking to our customers mainly, as well as conferences like this. We're sharing the journey because cognition in the enterprise sense is new. That's really not something that's been tackled before. And so we think that there's some fundamental differences there in terms of how cognition's been done in general in a consumer-oriented space. And so in some sense, it's going to lead to new problem sets, new problem domains for the AI community. And so we really want to share the journey, and in a sense, we're trying to attract folks to join us in this journey as we move forward. So that's the backdrop on this, for this talk. I'm going to essentially step through a few background slides just to give you a sense of the toolkit that's at our disposal at IBM to be able to create this cognitive business. Then we'll get to the enterprise itself. What will a cognitive business, in an enterprise, what does that look like? And then finally, I'll leave you with a few examples of how things are going to be different in terms of how they're done today versus, how they're going to be done when we are a fully fledged cognitive business. So with that backdrop, let me just move to the next slide. This is the background slide. Data is the basis of competitive advantage. Now, I have to tell you, it wasn't always like this. And when I started out in this business, the way people viewed data was more as exhaust. So you're running a business, some data is created, and then it's not really fundamental to the business, it's treated as an exhaust. That's very different from what it is today. Today it's currency, it's actual currency. Another way to think about it, in those days I would often get the attitude from the business side that would essentially go something like this. Just give us the damn data and we'll be able to run the business. That's all we really care about. Just give us the data. We've got everything else figured out. And now of course it's very different. I mean, it's, in some sense, data drives the strategy. It's a key part of the strategy of the company. Just to give you the IBM example, our strategic monetization strategy as a company, just put the data aside for a moment, but as a company, it's all about cognition. So our data strategy essentially hinges on enabling cognition in a cognitive business. And so my task is front and center in terms of driving that strategy by implementing that within IBM itself. So that's an example of how things have changed from where they used to be before. Another backdrop slide. This is a journey that we really can't do alone. We need a full ecosystem around it, and I'm not going to go through the details of this slide, but you'll probably recognize several of the symbols. We have several partners, externally, as well as significant investments in open source, SystemML, Spark, and so on and so forth. So those are all part of the toolkit that's at our disposal as we move forward in this journey. Tell you a little bit more about cognitive systems. So how do we think of a cognitive system, right? Because before we go off and talk about making a cognitive business, I'd just like to give you this background. This is really our point of view. This is how IBM looks at it. It's a view of augmented intelligence, more so than complete, fully automated intelligence. But there are the 4 E's that are critical to a cognitive system. So in our view, if a system has these 4 attributes, then it's cognitive. So first and foremost, the system has to be an expert at something. It could be a domain like oncology. It could be an internal domain like procurement. But essentially, it's an expert at something. Secondly, they must support expression, natural forms of expression, because these systems deal with a human who's making a decision. So there's a human, they've got, they're exercising significant judgment, making a decision, and we have now this system that is going to interact with the human naturally, so it must support these natural forms of expression. That's the second. Thirdly, the system must learn through education. So in a sense, it's not about coding, it's about training. So these systems are trained, they're not programmed or coded. And so then that again goes back to this notion of the kind of human that is working with the system. More likely than not, it's going to be a subject matter expert as opposed to a technical person. So that's the 30. And finally, these systems must evolve. As they see more data and get more input from the human, they evolve, they learn. And they do this at scale, right? That's, of course, the most important element of this. So I'll just step back a little bit and reflect on a couple of insights as to why this is so important. First and foremost, it's all about the data explosion, right? So today there's just tremendous amount of data that we're overloaded with, and we're not able to look at all that data. So as you well know, if you're making decisions with incomplete information, it's not going to be a very good decision. So that's one aspect that's handled by these systems. The other aspect is a little more subtle, and it has to do with presenting data in context. You've all heard about actionable insights and so forth. If you think about what makes insights actionable, it's really about having the context around the data to be able to do something, to be able to act on it. I'll give you an example from my first go-around at IBM, where I had created this system that ended up being used by every coach in the National Basketball Association. And in one playoff game, this system came up with a finding which essentially said that the team, in this case it was the Orlando Magic, that they had to play 2 backup players in their starting lineup. They had to play their backup guard and their backup forward. And the team was down 2-0 already in this playoff series, facing elimination. You can imagine the effect that had on the coach. How do I believe this? That's really the question. How do I know it's right? What if it's wrong? I'm going to look like a complete fool, right? So eventually we solved that problem by understanding that if we presented the clips of video that corresponded to those circumstances, the coach would be able to act on it and make a decision. And they did, and it was a successful decision. But that's the fundamental problem behind data and driving insights from data to make them actionable. And these systems, by supporting these natural forms of expression and so forth, are actually able to present data in context. There's yet a third fundamental aspect, but I'll get to that later towards the end of the talk. So that's basically what we mean by cognitive systems. Just a few examples to bring home those points. Watson for Oncology, used at a hospital. This is the Bhandari Hospital in Thailand. Now, Watson for Oncology, Memorial Sloan Kettering spent 15,000 hours actually training it, using 1.2 million patient cases, well over, I think it's 200 million pages of text, and so on and so forth. Tremendous amount of knowledge going into training the system. And now, the doctors at this hospital in Bhandari, which essentially caters to, I believe it's 16 countries, and they have well over 1 million patients who come to them from these countries. They're able to keep up with what's happening in oncology. And so it assists them in moving forward with that. So back to that point about data overload being able to deal with that, the system does that. The statistic is that by 2020, medical knowledge will double. In every 73 days, I think it's going to double. So you can imagine the overload on the doctors. They need to spend, I believe it's like 140 hours a week just to keep up with what's happening. So obviously not doable, and that's where a system like Watson comes in. This is another interesting example. This is an example of Watson creating a trailer for, it's an AI horror movie called Morgan, and this trailer was created by Watson by essentially analyzing 100 trailers, and it analyzed these trailers along 3 dimensions. The visual analysis as to what's on the screen for these trailers, a audio analysis in terms of the sound effects that were present, and finally a composition analysis in terms of actual lighting, location, and attributes like that. So it analyzed these aspects of 100 trailers, and then it was able to put together an actual trailer for this movie, working with a human editor. So there again, there's that human element that comes into that, but this whole aspect of being able to automate a creative process in this fashion, an example of being able to put things in context and present them. Cognitive advertising, this again goes back to just-in-time data, again presented in context. The idea here is to make use of our weather-related information. We did acquire the weather company, and we have hyper-localized weather data, and analytics on that, as well as being able to do predictions on that. The idea here is ads are served up in context. The first one, I believe, the pilot is with Campbell's soup, and then if somebody clicks on it, they're able to get soup recipes that pertain to their particular situation with regard to their location, the weather at the location, and so on and so forth. You can just extend the idea as to where all that could go. And this one is actually a really good one in terms of bringing home the point. The connected cockpit. As you can imagine, as planes fly, for the most part, that's a very, very structured process by now and well understood. The one variable is the weather. And so again, the idea here is to provide to the pilots hyper-localized information about weather, as well as turbulence, and so forth. You could almost think of it as a GPS around weather alerts, but that's being crowdsourced because it's on planes that are flying around, and then essentially a pilot is able to get this information properly visualized and rendered, so that they're able to act on it and avoid turbulence and unpleasant aspects like that quite easily. Finally, this is the brain-inspired computer chip called TrueNoth. It's based on, the scale is 1 million neurons, 256 million synapses, and as a result, it's able to process images very, very rapidly. I think on average around 2,000 frames per second. It also is able to do it with very low power. So roughly, I think it's 6,000 frames per watt. So again, very powerful capabilities, very powerful technologies that are able to you're able to then apply them to these applications that all eventually go into AI systems and cognitive systems. Okay, that was the background. Let me switch to the enterprise and what cognition means for the enterprise. So first way to think about it is think of all the processes that make up a business. So here I'm talking about customer service, research, marketing, and so on and so forth. And the idea here is to make each of these processes, in some sense, a self-learning process. And I'll talk more about that as to how we go about doing that. But what you want to do is transform each process to become cognitive in that sense. And it's applied across the entire business. On the left side, you see there's also a data transformation that's obviously going to be necessary to do this. And the examples I'll work through will shed a little bit more light on them. And when we talk about the data transformation, I'm talking about the technology stack, the people, the processes that they have. All these will change to support this cognition that you render into each process so that it becomes self-learning. That's one way to think about it. I'll give you another way to think about it. Another way to think about it is if you visualize a curtain and there's a subject matter expert who's working in a particular process, like procurement or customer service, and the subject matter expert is able to step up to this curtain. Behind the curtain is the gigantic brain, Watson. And very quickly, the subject matter expert is coming in with some use case or hypothesis or something like that in mind. Very quickly, working together with Watson, the subject matter expert is able to arrive at an understanding of what data, internal or external, structured, unstructured, semi-structured, is relevant for their use case. As well as Watson behind the scenes is able to then essentially go after all that data, hide the complexities of different formats, different silos, all that kind of stuff. Together they're able to cross-link the data conceptually in the sense that a client in this data set is likely a client in that data set and then should be related. And then they're able to work towards deriving insight from that data. So this, you can think of this as being done across all processes, with subject matter experts being able to access a capability like this to become much more cognitive in terms of how they were doing things today. So a little bit more to bring that home, I'm going to step through some examples. And then just to go back, on the left side, there's also a corresponding data transformation along the lines of technology, people, and process that has to support what I just painted, that vision around the subject matter expert working directly with the brain. So I'm going to give you a few examples now of actual transformations, and on both sides, so you begin to gain an understanding of what this would look like. So I'm going to start with an example that has to do with my area. Right, I'm responsible for master data as part of our operations, in addition to the strategic initiatives we just talked about. And as part of master data, one really important judgment that we have to reach when we're working with our clients, we have to reach a judgment on whether or not the client is a government-owned entity. And why is that important? If you operate globally, there are different laws and different regulations as to how you deal with government-owned entities. You can't bribe them, you have to run an ethical business. As it's something extremely important to us. It's important to arrive at that accurate classification. And you can now visualize how this happens today. Right? There's somebody in my area who's responsible for this judgment, and they have access to some data, some analytic tools. They can also call people in sales who are also jockeying for a classification that could potentially be easier, make what they're trying to do easier. The accounting folks have a say in this, the legal folks have a say in this. You can imagine how that flow essentially goes through management, maybe up to management, escalate, then over to the a particular area, silo, look at their data, back and forth, and so forth. And in the cognitive sense, this is one of the main themes in terms of the differences that will emerge. Data becomes the middle manager. So now these subject matter experts across these different areas all stepping up, dealing with Watson. And so in that sense, a lot of that inefficiency is taken out. The second aspect of this is, along with the input that's coming back from these different subject matter experts, this brain also has access to all the data about these decisions that have been made in the past. And so it's able to tap into that and essentially learn from that as to what makes sense, what doesn't make sense, all the while working with the human expert who's finally responsible for making this call. Thirdly, it's able to go after exogenous data, right? Data that's outside of the IBM environment, in terms of news feeds, in terms of social media, and gain an understanding of what's actually happening with this entity right now, as of this moment. And so you end up in a situation where you're able to make a more accurate decision, a more efficient decision, by virtue of the fact that you've got this, this brain that's essentially guiding the process and is also able to evolve it, right, to learn with it, so it gets better and better over time. And so the two themes in terms of differences as to how things are being done today versus tomorrow, data is the middle management, that's one theme. The other major theme is this around exogenous data, that you're able to bring that in a major way to work with this decision. And then another example I'll give you is around product announcements. This is another aspect that is a complex aspect at a company like IBM. We operate globally, we have very large numbers of products, and as you can imagine, we also have very large numbers of customers, so we announce a new product, we have to enable the system in a way that our customers can come and rapidly get data that's accurate, and so forth. And so, in this context, stepping up to that curtain and talking to the brain obviously gets us again to efficiency, more accurate announcement, but there's also another aspect here that is subtle, and I'll tease it out. Today, as we announce new products, there often are times where it ends up in somebody writing a bunch of code just to make sure that the systems that are being exposed to our customers and partners accurately reflect those products. Now again, in the context that we're talking about, the cognitive system, it will have access to all the information about all our previous products. The initial request for announcements, what the eventual announcement looked like, what was the code that was implemented to code the features of this particular product, as well as the exogenous data in terms of what the competition is doing, and so on and so forth. So the theme there is we're going to move from what potentially is a programmatic process today to one that goes directly into a much more insight-driven DevOps style process. And so go directly into insight, because the systems that are going to be in place, this brain will already be trained, will already be educated, and there will be no reason to write code or perhaps even change business rules. It can actually be automated in that fashion. So I have additional examples. I'm trying to get a sense of how much more time I have. We're about done. So let me stop there, and I'll just kind of just summarize this. The exogenous data, there's one fundamental aspect. Remember, I told you there'll be one more fundamental aspect I'll address. What that exogenous data allows us to do is it makes the system open loop. So traditionally, right, if you think in terms of modeling and analysis and so forth, we develop a model, and then it scores new situations as they come in, and it classifies things. High credit, low credit, fraud, no fraud, etc. In an exogenous system, it's open loop in the sense you can get in the latest information, the new information. You can make judgments like, maybe this should be treated as a government-owned entity. Those kinds of things. So the black swan effect, which has been traditionally in these closed loop systems, you potentially have a way to address that. So that's kind of the other fundamental aspect that I'll leave it. So with that, let me pause. I don't know if they'll allow a couple of questions or not, but hope I gave you at least a fair understanding. It is early in the game for us as we move forward with this. I've been 9 months in the job, but we are going to be essentially sharing our progress as we go. And we hope you decide to join us in the journey, whether it be as part of IBM or whether it be as a partner or as a client or even as a competitor. But we think this whole space around the enterprise is going to lead to a different set of problems for AI to solve. Thank you.